Hello and welcome back to Chem Talk. On today's topic, let's talk a little bit more about bond energies. So, what is bond energies? So, bond energies can be defined as the amount of energy needed to break 1 mole of a certain bond. So again, 1 mole being 6.022 times 10 to the 23. And those bonds have to be in the gas phase. So let's take HO bond, hydrogen and oxygen. So that bond has a bond energy of 459 kilojoules per mole. So what does that mean? That means 459 kilojoules of energy are needed to break 1 mole of hydrogen, oxygen, or HO bonds. So bond energy is in the unit kg per mole. So this relates to endothermic and exothermic reactions. So what's endothermic? That means the reactants absorb heat energy from the surroundings. And what that means is that bonds breaking is an endothermic reaction because the reactants are absorbing heat energy to break those bonds. So as you can see by the image, the bonds are intact, but then when you take in the energy, the bonds break. So that's how they work. But what's an exothermic reaction? An exothermic reaction releases energy. So reactants release energy into the surroundings. That's what an exothermic reaction is. So again, that's bonds forming. Bonds forming is an exothermic reaction because you're taking broken bonds, you're releasing energy, and then it's forming the bonds. So endo means add, and exo means release. That's how you kind of think about that, like that prefix. Endo is add, exo is release. So let's take a reaction. We have H2 plus Cl2 produces 2HCl. So H2 is HH bond, Cl2 is Cl-Cl bond, and 2HCl is 2 HCl bonds. So again, that coefficient represents the number of bonds. So to calculate the overall energy change from the reactants to products, it's energy required minus energy released. So let's take a look at this. So we have the numbers written out, and that's how much the energy is needed to break that bond. So if you plug everything in, using that chart, you should get negative 185 kilojoules per mole. That's the overall energy change. And if that number is negative, that's an exothermic reaction because it's releasing that energy. But if it's a positive number, it's an endothermic reaction. So in this case, this reaction is an exothermic reaction. And that chart, you will be given that chart. In most cases, you don't need to memorize the bonds. But yeah. So let's talk about bond energy, strength, and length. So bond strength is how strong the bond is. And we already know that bond length is how long the bond is. We already know what bond energy is. But they're actually related. So bond energy and bond strength are a direct relationship, while bond energy and bond length are an inverse relationship, and bond strength and bond length are also an inverse relationship. That means for bond energy, the stronger the bond, the higher the bond energy would be because there's more energy needed to break the stronger bond. And then for energy and length, the longer the bond, since it's an inverse, it's actually the weaker or lower the bond energy will be because the lower the bond, going back to strength and length, the shorter the bond, the stronger the bond it actually is. So you need to remember those things. So application. How is this important or how is this really used? Let's take a look at fats and carbs. So fats are actually used to store energy, and they have a CH bond. And that CH bond is actually a really strong bond, meaning, going back to that bond strength and energy, it has a really high bond energy. That means it's really a lot of energy is needed to break that bond, meaning that fats are easily able to store that energy, and the CH bonds kind of protect it because to take away that energy, you need so much energy to break that CH bond. While carbs, they temporarily store energy. That's why when you go for a run, you try and eat a lot of carbs. So the bonds aren't as strong. So that's why the carbs are temporary, while fats are actually long time. So let's recap. What is bond energy again? Bond energy is the amount of energy needed to break 1 mole of bonds. Again, in the gas phase. So exothermic, remember exo, it releases energy into the surroundings, while endothermic, again, endo, absorbs or adds energy from the surroundings. It takes that in. So how do you calculate the bond energy or overall energy change? It's energy required minus energy released, and it can be a negative thing. So again, the relationship between bond energy, strength, and length. So bond energy and bond strength are direct, meaning the higher the strength, the higher the energy. Strength and length are inverse, meaning the higher the strength, the lower the length, or the shorter. And length and energy are inverse again. So meaning the longer the bond, the lower energy needed to actually break that bond again. So let's do a little bit of practice problems. So number 1 is bond formation exothermic or endothermic? And calculate the overall energy change. So again, in the little bit, left corner, you could say, I gave the bond energy, the values. So you just have to use that formula and apply that knowledge to do that. But yeah, this time, the answers will be in the comments below. Take a look at this. If you need help, try and do it. But the answers will be in the comments below, so make sure you check them. But thank you, and follow Chem Talk for more chemistry help and practice. Thank you again.